Hi, welcome to your lesson on direct versus indirect variation. This diagram in the background here shows direct variation, and maybe this topic has been a little tough for you so far, but this is okay. Don't freak out. It's not a bad topic. There's just a few key things to remember, and you can basically solve any problem if you remember those few things. So let's begin with a recap of what direct variation is and what inverse variation is. Direct variation is basically any relationship that looks like this. Y equals some constant number, that A represents some constant number. Often you'll see that a K used to represent that, and then times X. This you may recognize as a linear equation. Basically, you probably have learned linear equations as looking or taking the form Y equals mx plus b. So notice this is just linear. This is like your mx. There's no plus b. So the A is like your m in a linear equation, and the m in a linear equation is a slope. So if you look at this graph here, direct variation always looks like this. It's always linear. And this A value is your slope of this. So if that A was a 3, that would mean this goes up 3 over 1, up 3 over 1. It has a slope of 3. Again, this thing has no B value. It means it has no y-intercept. Usually a linear equation is mx plus b, b being the y-intercept where the graph hits on the y-axis. But here we have no b value. That means the line will hit the y-axis at 0. So that's direct variation. In direct variation, to solve the a value or the constant value, we can just rearrange this equation by dividing by x, and we get a equals y over x. So that constant value is always going to be your y divided by x. Now let's look at inverse variation. This is also called a reciprocal function. Inverse variation always looks like this. It's similar to that, except for you have your constant a value on top, and then there's a fraction with the x on the bottom here. That, when you rearrange it, if you multiply by x on both sides, you can get this equation. That means to solve for the constant a value, all we have to do is multiply your y and your x values. Inverse variation will always graph to this shape here. All right, let's look at some examples. So again, direct variation, inverse variation, and let's look at this. We looked at this one in class. Let's say you have a bottle of kvass and it costs €50 for one bottle. The cost of buying kvass Y varies directly with the number of bottles you buy. That makes sense. If you buy one bottle, you pay this much. If you buy two bottles, you pay twice that much. If you buy three bottles, you pay three times that much. So here's your equation, direct variation. The amount you pay is equal to the constant, which is 1.5, because every bottle is 1.5, times the number of bottles you buy. So if you substitute a 1 in here for one bottle, you'll get 150. If you substitute a 2 in here for two bottles, you'll get 3. And we can see that here. One bottle, 150. Two bottles cost 3. Three bottles cost 450. Four bottles cost 6. If you graph that, you would see exactly like that. Here's the cost of bottles. Here's the number of bottles you bought. And it's linear, with 1.5 being your slope. It's rising 1.5 over 1. Rising 1.5 over 1. This a value, again, is like your m, or your slope of this linear equation. Let's look at one that's now inverse variation. So we also looked at this one in class. We have a pizza. The price of a small pizza is €6. Cost per person varies inversely with the number of people sharing. And the inverse relationship is like this. So the cost per person varies inversely with the number of people. And 6 goes on top here because basically you take the pizza cost and you split it by the number of people that are eating. So here's our table. If one person is buying this pizza, they pay 6. If two people are sharing this pizza, they each pay 3 because it's 6 divided by 2 people. If 3 people are sharing, they each pay 2. Again, it's 6 divided by 3 people, they pay 2. That graphs like this, and we see it's inverse, and that makes sense for this example. Let's look at two more examples here. The variable y varies directly with x. When x equals 4, y equals 10. So y varies directly with x. When you read that, you can right away say the a value must be y over x. All right, because that's how direct variation works. So here we're given an y value of 10, x value of 4, and we find out 10 by 4 is 2.5. That means when we write our direct variation formula, our a value must be 2.5, which we just solved. And there's our equation for this situation. Then it says find the value of y when x equals 7. So now we have the equation created, we have our constant value figured out, and now we just figure out what are we looking for. We're given x equals 7, so we put 7 in there, and we find y to be 17.5. Now we have another example. The variable y varies inversely with x. And in inverse variation, we always use this equation to solve for the constant value, y times x. So now we're going to do 4 times 10, which is 40. That means our inverse equation is this, but we just found out the constant a value is 40, so we're going to replace that with 40, and now we have our model or our equation for this inverse relationship. And then we see, well, what are we looking for? Well, x is 7, what is y? So here we have our equation. We're going to plug in a value of 7 for x and find out what y is. In this case, it's 5.71. So the steps are simple. You might be given two values. Those help you get the constant, and then you create your equation and use your equation to solve other values. Let's try one here. The number of cars in a parking lot C varies directly with the minutes after 8 a.m., which are going to be represented with M. When it is 8:38, there are 114 cars. Write an equation. So begin by figuring out, well, the equation. This is direct variation. So let's write a direct variation equation. I'm going to use k now instead of a because sometimes you're going to see k, so let's get you guys used to that as well. It says use the C for number of cars in the parking lot. So C, the number of cars in the parking lot, varies directly. Directly looks like this, with some constant and the number of minutes after 8. So based on that, can you figure out this equation? In other words, figure out what k is and then rewrite this with that value for k using the information you have here. All right, in this case, we were told that when there are 114 cars, the time is 8:38. So it says here the minutes after 8 a.m. At 8:38, it's 38 minutes after 8 a.m. So the minutes value is 38, and there's 114 cars. That allows us to solve for k. You can just divide by 38. K equals 3. Now that we know k, we can rewrite the entire model, and we know the model for this direct variation is number of cars varies directly, 3 times m, the constant is 3. Now we can use that model to solve things. So here it says at 8:14, how many cars were there in the parking lot? So solve that. All right, let's use our model. At 8:14, we are 14 minutes after 8, so 14 goes in there, and that works out to 42 cars. Okay, let's look at another one. The cost of gym membership, G, varies inversely with the number of weeks of membership, W. So we're going to use G for the cost of your gym membership, W for the number of weeks. All right, with 5 months of membership, the cost was €15. All right, this one it says varies inversely, so we're going to begin with an inverse model, and we're using G to represent your gym membership cost, and it's an inverse one, so it looks like this. Here's our constant. W will be the number of weeks. So see if you can use this information given here to figure out what this equation should look like with the k value put in there. So figure out k and then rewrite the equation. Right, so in this one, you're given the gym membership is €15, so here, and you're told 5 months. Maybe you put 5 in here. That would be wrong because be careful. In the problem it says G varies inversely with the number of weeks of membership, and then here it jumps to 5 months of membership. So how many weeks are in 5 months? Well, there's 4 weeks in 1 month, so 5 times 4 is 20. 5 months is actually 20 weeks of membership, which I put in here. So membership is 15, 20 weeks. You have these numbers, 15 times 20 will give you your k value, which is 300. So now this model for this situation should be G equals 300 over W. This is now our constant value, and now we have an equation where we can plug in G or W to solve. So if you joined for 50 weeks, how much would you pay? Right, using our model, now we're told we're joined for 50 weeks, so the W becomes 50. We have 300 over 50, which is, excuse me, maybe you can't see it down there, but it's G equals 6. So the cost of membership is €6 when you join for 50 weeks. All right, so looking at these, which is it? So if you're given a table of values and you're asked, well, is this direct or inverse variation? You have to look at the values and figure it out. Again, with direct variation, you will get a constant value. Your constant will be figured out by dividing by y by x. And that should work with every case. If you divide y by x here, 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 in every point, you should get a constant value. If it's inverse variation, if you multiply the y and the x values, you should get a constant value. So let's try here. What happens when you divide y by x each time? And what happens when you multiply y by x each time? So think about those values or calculate them, and then decide, is this indirect or direct? And what is the equation? Okay, well, in the first one, if you did y divided by x, you would have gotten 300. And then if you did y times x, also 300. That doesn't help us yet. Next one, if you did y divided by x, 18.75. If you did y times x, 300. Filling in, and so on and so on. You notice the only one that has a constant value is y times x. And if y times x is a constant value, this must be inverse. So this inverse variation must look like this, and we just figured out that constant value is 300, so this is our inverse model here. Next one, which one is it? Try that as well, y divided by x and y times x, see what you get. Hopefully you got values like this. All right, y divided by x in every case gives you a constant value, but y times x does not give you a constant value. So that means this must be y divided by x constant value, therefore direct variation, this model, and we found out the a value is 260, which gives you that model. Okay, here's some samples from the work we've been doing. This one was, I want you just to pause the video and study on your own, but we did this one in class already. You might want to look at it one more time. Basically, it tells you it's direct, I think. Does it say that? Yeah, confirm it's direct variation. So we're trying y divided by x. We get 0.8. Tried it with two other values, 0.8. And that means a is 0.8. Our model must be 0.8x. And therefore, if you're finding a value like in part C, now you're plugging in x value of 5 containers in there and finding out what that is. Again, I'm kind of rushing through this. I know I have a few minutes left in the video, so make sure you study this one and read it carefully and understand what's happening. All right, same with this one we did in class as well. We're going to fill in those values. I want you to also consider this one, all right, because time is short, so see if you can figure this one out. But basically it says you're figuring out the time it takes to prepare a field, and you should notice it's inverse. When you do y times x, it's always constant, therefore our inverse model is this. And you can use that inverse model to solve part D, which says there are 17 workers and you have to figure out the days. Let's move on to some problems we haven't seen yet. The samples that we were looking at in class last time, I'm going to have to make a second video for. This is turning out to be a longer lesson than I expected. So study this presentation. Definitely go back to the few that we looked at here. These last two samples. If you had trouble with those, make sure you study those carefully. This one and this one. See if you can read the problem and understand what was done here. And then I'm going to take you in the next video to the next step, which is looking at inverse direct variation with some tougher problems. And let's see how those go for you.